Morning. My name is Celine O'Connor and I'm a BIM manager with Rhatigan, and I'm responsible for the implementation of BIM across all of Rhatigan's Leinster projects. So just to start, a few points on Rhatigan. We are an Irish-owned company, a building contractor with over 60 years experience and 500 employees across 5 locations in Ireland and the UK. So we are BSI certified to deliver BIM Level 2 projects to PAS 1192 standards. And most of our projects now are BIM jobs, which have 3D models associated with them. And those that don't have models draw heavily on BIM workflows and practices for sharing of information. Now, some of our BIM projects are client-driven, with the employer's information requirements issued at tender stage, such as Trinity Business School. However, more so now we're electing to, where there are no BIM requirements from the client, we're electing to implement BIM ourselves because it's a real benefits that we've seen on projects such as Trinity Business School. So we've heard already about BIM and the business school from the architects and the structural engineers perspective, and I'm going to speak about BIM from the contractor's perspective at construction stage, which is this area here highlighted in the information delivery cycle, which diagram I'm sure you're pretty familiar with. So Trinity Business School, we were awarded a contract in July 2016, and we started on site very soon after in August 2016. With a 2.5-year construction program due for completion in December of this year. Currently on site, there are a few rough images there. Currently, the structure is all complete. Internal first fix at all levels is well underway, and 40% of the facade is complete at this time. So in kind of running with the theme of the other presentations, I'm going to discuss some of the successes that we've seen on the project in terms of BIM, and also some of the challenges and kind of room for improvement and how we've tried to overcome these challenges during the construction stages. So this slide summarises both successes on the left-hand side and the challenges on the right-hand side. Now, there's been a lot more than these, but I suppose we have limited time this morning, so I'll just speak about 3 of each. The successes on the right being the models used for coordination, and the models as a really valuable source of information for us building on site, and also the really high quality construction documentation that has been derived from these models. And then on the right we have the challenges, which have been kind of the model and what has been inputted in the model at handover stage. As Liam and Adrian have mentioned, the question of model ownership at construction stage, and also the model status when they're issued. So I'll explain these in a little bit more detail in the coming slides. So the first key advantage for BIM we've had on the business school has been BIM for using the models for coordination. And that's really invaluable for us as a contractor. It's basically making sure all the bits of the puzzle fit together before we get to site. So on the business school, we have several models, individual models that are merged together to form the federation model. And we use BIM 360 Glue as a platform to host the models on the cloud. And coordination has been primarily done through Glue and also Navisworks. And there's just a screenshot of the homepage of Glue there for the project. So the advantage of using Glue is that it's a cloud-based platform, and when a new model is uploaded, it supersedes the previous one. So we all know, the whole project team knows that we're working on the most live current model. So I'll quickly run through the models that we have incorporated into our federation model. As Liam mentioned, we had a really good existing site model, or site survey model, and this has been really useful for us from the outset, kind of plotting, because it is a very tight site, plotting out where we're going to put our site cabins, our compound, our hoarding, our scaffolding, and our cranes as well. And then we have the civils models, and of course the architectural and structural models. So those were the models that were kind of handed over to us at tender stage. And also we had the MEP schematic model, which was developed by Into. And then we took this model and separated it into two, the electrical subcontractor designer group and mechanical, which was T. Burke, developed their own individual MEP and elect models. We also had the structural steel model, as Adrian mentioned. And then we have various other models that whenever we need to do a bit of analysis, we would in-house kind of do up these models, import it, and check for clashes. So we have the crane models, we have, this was a little 3D room tag model we developed, so when you're navigating through the model in glue that you can clearly identify, because there's so many rooms in the building, identify what room you're in by a little, looks like a man, but it actually just says the name of the room and the number on it. And then we had a siphonic drainage model as well. And there was a few more little bits and pieces models that we didn't put as well as that. So basically, by federating all of these different disciplines models, we can straight away see the clashes and start to fix them. The models are especially useful for us when it comes to builders' OAPs and setting them out really accurately and making sure that there's no clashes. So ensuring they're all well coordinated with the services for when we get to site, reducing the amount of sporadic coring that we need to do. The coordination has worked really well. Actually, one particular area is in the basement. We have a large, heavily serviced plant room. You can kind of make it out from the top image there. There's a lot of stuff going on there. And I was down on site last week, actually, and speaking to the M&E services coordinator. Most of this stuff is installed at the moment. And he said that there's actually been no coordination issues whatsoever down at that basement plant, and attributes it largely to the really good work that had been done in the models, coordinating that before we get to site. So yeah, it's hard to get an overall photo of the plant room down there, but there's just a comparison between the ductwork shown in the model, and then that's the ductwork actually installed on site at the moment. So it's quite very similar, the two, virtual and in reality. The next advantage we've seen, or success I'd like to highlight, is that, and this may be an obvious one, but on Trinity Business School we've found the models as a really good source of information. And the site team would regularly refer to the models for clarification, just where there might be some kind of any ambiguity in the drawings, or where they just really wanted to see what was going on in a particular area. They could quickly log into Glue, put a section through it, have a look, and just really analyse what's been going on. And this has, a lot of the times, this negates the need to issue an RFI and go into that process, which can sometimes be quite lengthy for all involved. So also the models have been really useful using at design meetings and site meetings to explain the building and an issue at hand. So it brings a lot more efficiency to the meetings because you spend a lot less time explaining an issue and more time resolving it. And finally, the last positive or advantage that we've seen on Trinity Business School, and Celine kind of touched on this, but the fact that Revit is a great documentation tool, not just Revit, but any authoring software is a great documentation tool. And this is really evident when we come to site to see, to build off the drawings that have been produced from the models. We find there's a lot more consistency in the information once they have been derived from the models. The quality of information on 2D traditional projects, this of course can be really high, but we definitely see a lot more discrepancies in between packages, and this can cause confusion on site for the guys building it and for the QSs, and meaning that they often need to raise RFIs, which tends not to happen as much on the 3D BIM projects. So just emphasising that, and the guys already have that, on a BIM project we would emphasise that all the drawings really need to come from the models as background information. And so in saying that, on Trinity Business School, yeah, just to emphasise how all the revisions have worked really well, like the PAS naming convention, which has really been useful on this project, the standard naming convention. And the convention also we have that rolling across most projects now, and it makes a lot more sense for when we have teams moving from one side to the other, and the file naming convention is just legible from one project to the next. So there are kind of three main benefits or advantages, and the next I'd like to talk about is kind of the challenges that we faced on the project. The first challenge, I suppose, that we kind of faced was the models at handover, at a tender stage, essentially. So this diagram, very simple diagram, kind of explains that we have these models, and they are starting off with the design consultants, then they're passed on to the contractor during a construction stage, and then they're on to the employer at the end. So, and each of these parties kind of needs the models for different purposes. At the end, we have the employer or the client, and they need the model predominantly for asset information and facilities and operations at the end of the project, amongst other things as well. But they clearly set out what they need from the model in the employer's information requirements, which is issued to all parties on the project, and we all kind of know what we're gearing towards. Then we have at the start the design consultants, and they're starting the models from scratch, and they know what they need the models for, actually producing designs, coordinating with the other design consultants, and also, of course, producing documentation for the project. So then we have the contractor, us, in the middle, but we need the models for our own set of purposes, which is cost analysis, programming, and of course coordination. So, but nowhere in the sequence here in the contract designed by the employer is an opportunity for us to kind of relay to the design team what we need the models and what we need incorporated into them. So luckily on Trinity Business School we received very high quality models now at handover, or at tender stage there. But that kind of is just it. It's kind of down to luck as to what we receive on probably a pen drive at tender stage. And because of this lack of communication between the contractor and what goes before us, there are naturally things missed in the models. I'll give you one such example. This was just one minor one on the Trinity Business School project, where you'll see here on the left we have a partition coming down to floor level. But then when we look at the detail, we see there is a fire barrier underneath that particular partition type. So that hadn't maybe on model, but it was in the detail. So a bit like what Adrian and Liam have been discussing about what's in the model and what's in the details. But we really needed those to be in the models because we're going to be passing services through them. And we needed to coordinate where we were going to put our fire stoppers underneath. Or fire damper, sorry. So this was kind of one example on the business school. Unfortunately, we had a design team that really wanted to see these models used to their best effect at construction stage. So we kind of informally agreed that Rhatigans would go away and analyse the models that had been handed over to us and essentially write a kind of list of changes or updates or requests that we put in to be added into the model or changed. And it kind of worked out relatively well. Scott's and ARC's went away, did a few changes and reissued them to us. But going forward, we'd like to see a lot more, I suppose, procedure involved in that. And maybe, as I suggested in this one, we do have a contractors information requirements, or maybe it's a kind of an industry-wide standard of models, what's included at the models at tender stage. More than just an LOD3 or LOD4, which can be a bit vague. So the next kind of challenge we face, and it kind of follows on from the handover, is the question of the model ownership at construction stage. So this is an extract from the EIR. It's a bit blurry, but basically the cells highlighted there show in green MCon, which is the main contractor. And at stage 4 and 5, we essentially own all the models, including the architectural and the structural at construction stage. Now, this isn't typical, I suppose, to Trinity Business School. We see this in a lot of EIRs coming our way. And for some models, it is kind of straightforward, as in for the MEP schematic model, we take that and it's subdivided into 2 other models, and our subcontractors work on those. But it comes a bit more grey when it's like the architectural model and the structural model. So what happens, like it would be perfect if there was to be absolutely no changes post-tender, but I'm not sure what project in Ireland that's ever happened at. So what happens if the architects want to update a partition layout, say for example. They need to update the model to produce the drawings and then issue the drawings to instigate the change. But how does that happen when the contractor owns the model? So at the beginning of the project, we had a lot of discussions how this might work. We spoke about kind of us taking the model and then sharing it back and forth between us and the design consultants. We spoke about maybe us both accessing the model off one server and also having actually 2 architectural models running in tandem and the changes being made in both models, which just didn't really make sense at all. None of those solutions made sense. So in the end, we kind of came to a resolution that every time there was a batch of significant design changes, the design team would reissue the model to us. But it kind of goes against what was said in the EIR. So again, going forward, we'd like to see a bit more clarification on the ownership of the models and the various disciplines models and even the elements within those models, who actually owns them at construction stage. So the next, I suppose, challenge and final one I'll discuss today, and Liam spoke about this a little bit, but it would really be invaluable for us for the models to be issued for construction rather than for information. Again, this is not specific to the Trinity Business School project, but it's kind of industry-wide at the moment that the models are issued for information. And our QA procedures would never really allow us to build from a drawing that's issued for information. We don't even like to have them on the sites. They should all be stamped for construction. So really, when a model is issued for information, well, we can't build from them at all, and we shouldn't really be going into the models to take a ceiling height from them. And it begs the question, should we actually be using them for coordination at all, which is our main driver for BIM? So I'm not quite sure why this has kind of become the norm. It may be because task teams don't yet have the confidence in their modelling capabilities, or maybe it is, as Liam alluded to, that some parts of the model might be deemed finished and other parts are still up in the air. And I don't know, maybe it's something like a parameter is assigned to everything that's deemed for construction, and then the rest is for information, and we'd have to relay that back to our site team. But I think it definitely is something that needs to be addressed fairly soon in the industry before the models really, like, they're great for information, as I said in my benefits. We could go in and see what's going on, but really we need to be able to go in and trust them and be able to go out on site and take dimensions from them and build from them on site. Whilst always referring to the drawings as well, because I think we're a long way off models superseding the drawings yet. But yeah, so status code A would be great. So finally, in summary, on the business school project, definitely the successes have outweighed the challenges, and it's why we aren't using BIM in a lot of other projects where there aren't even no client requirements. The project was kick-started in 2014, actually. 16 is when we came on, or 13, was it? Yeah. And when BIM was really in its infancy in the Irish market, and it really has been a learning curve for all involved, and I think we all have take-homes that we're already bringing with us to other projects. And we are delighted that Trinity took the initiative to instigate a BIM Level 2 project. And so going forward now, we aim to hand over a really good set of asset-rich information models in December 2000 of this year, 2018. So that's it from me. Thanks very much.